Hello everyone. So in this question of the density of ideal gas, it's going to be slightly different because instead of finding the density of ideal gas, the density is given to you. But what you need to do is you need to find out what is the molar mass of the gas. That is number one. Okay, over here, that is the first thing you need to be able to do to find out the molar mass of the ideal gas. And then from there, you should be able to complete the second task, which is for you to find out what could it be? Okay, what is the possible gas if the gas is going to be diatomic? Okay, I think the word diatomic would be quite alien for some of you. If your English is not your first language, okay, diatomic simply means the gas will consist of two atoms. For example, of diatomic, the word di over there refers to double, okay, two atoms. So example of diatomic, O2, N2, F2, Cl2, what else? You can get Br2. So these are the examples of very common diatomic gas. H2 as well, so diatomic. So you can see that the molecule, all of them, they have two atoms building up that molecule. Okay, so you have two things you need to complete in this problem regarding to density of ideal gas. Yes, we're going to use the formula density equals to PM over RT to solve this. Okay, so I'm going to clear that out. I hope that is clear with you guys about the diatomic. Okay, so in the other video, we have talked about how to derive the formula for density of ideal gas, which is pressure times molecular mass or molar mass over RT. We have learned about this, how to derive this from PV equals to nRT. And now we're going to use this formula to find the molar mass. And after we have determine the molar mass of your gas, we should be able to identify what is the diatomic gas involved. Okay, so it's quite mysterious, it's quite playful, it's quite like a game. So the first thing you need to know is try to think about what formula you need to use. We have a lot of formulas in states of matter. Okay, we have PV equals to nRT, we have Boyle's law, we have Charles's law, we have Avogadro's law, and it's very essential for you to read through the question and try to figure out what the question wants. So it's very clear the question wants you to find the molar mass. And after that, we need to determine what is the diatomic gas. Okay, to find the molar mass, we're going to use this formula over here. And of course, you need to take out, okay, you need to extract given information from the question in order for us to solve this, okay? So the question gives, so if we're going to do that quickly, so the question gives you a few things. Okay, the first one, density is given to you. So we have the density, which is 1.70 gram per liter. Okay, so that is the density of the ideal gas. But if you read the question, it looks very simple. It looks really short. It's quite deceiving. Some students might kind of think, oh, this is easy. But when they read through the question, they will get very confused because it seems like the question does not give you enough information. Why? Because right now, you can see that there is only one piece of information that has number in it, which is the density. But what about the pressure? What about the temperature? We know that this R over here would be 0.0821. Okay. We know that already, but what about this? And what about that temperature? How do you get that? Okay. To say that the question is not complete is absolutely not right, because it gives you that piece of information, STP. STP stands for, okay, so you need to remember now. So the word STP, this is the standard temperature and pressure. So when you see this piece of information given to you in the question, so what you need to do now, you need to automatically think that the temperature at standard would be 0 degrees Celsius. And then the pressure at standard would be 1 atmospheric pressure. So in terms of the ideal gas law, we can see that the standard pressure does not require any conversion, but this guy over here, you need to remember, you have to convert this first. Okay, so when you convert that, okay, remember, we're going to use so we have 0.0 degrees Celsius plus 273.15. So you're going to get 273.15 Kelvin. So we have that temperature already. So next, what you need to do is, okay, what you need to do now, we need to use the formula density to find out the first thing we need to look for. Okay, if we're gonna go back here, the first thing we need to look at is the molar mass. Okay, we want to find that one. So we're gonna use the formula density equals to pressure molar mass RT. The density is about, just now we have, so for the density over here is about 1.70 gram per liter. And then the pressure is about 1.08 cm because it is at STP. Okay, so when it is given STP, you know that the pressure would be 1 atmospheric pressure. And we're gonna find this. Okay, so that is the unknown. And then R is about 0.0821. And that is your R. And then your T, just now temperature, that is 273.15 Kelvin. Okay, so when you rearrange everything, when you get all of this, all the blue one on that side, you will get something like 1.70 gram per liter, okay, times with 0.0821, liter HCM per mole per Kelvin, and we have 273.15 Kelvin divided by 1 ATM. Okay, so when you look at the units, ATM, you can cancel that out. Liter, you can cancel that out. Kelvin, you can cancel that out. So you are left with gram per mole, which is the units for molar mass. So the molar mass that you would be getting is around 38.12 gram per mole. So we have solved the first one. We have identified the molar mass of the gas. Okay, so molar mass of the ideal gas is 38.12 gram per mole. The second question asks you to figure out what is the diatomic. If this value over here is for a diatomic, so what would it be? Okay, so how do we do that? So we're going to look at your periodic table. But the problem with your periodic table is if we open up, okay, if we open up your periodic table, it gives you in terms of atom. You don't have diatomic. Okay, so when you click on this atom, it gives you this number over here. So that is the molar mass of the atom. Okay, so let's say if I'm going to click on carbon, click on here. So you have the okay, so you have the, I'm trying to look for, okay, the relative atomic mass is about since this one is for diatomic, what we can do, you take that number, 38.12 gram per mole, we can divide that with 2. We try to make it monoatomic. We try to make it one atom. So when you divide that into 2, so when you work this out, okay, 38.12 gram per mole over 2, you get about 19.06 gram per mole. So that one would be for, this is going to be for one atom. So when we know the information for one atom, it would be easy for us to identify what is the atom on your periodic table. So let's open up your periodic table. So carbon is 12, nitrogen is 14, oxygen is 16, nearly there. And look at fluorine, it's 18.9. So it's the closest one. When you look at neon, it's already 20. So it's not going to be neon because neon is group 18. Group 18, they cannot form diatomic gases because they are noble gas. Okay, so they can form monoatomic gas at standard temperature and pressure. So the closest one would be fluorine. So fluorine would be the atom. Okay, so we can say that this is for fluorine. Okay, so therefore the diatomic gas with 38.12 gram per mole would be F2. So that is the answer for question 2.